All right, let's take a look at question 8. So in question 8, you have the function f of x, which is this in the graph. But then you also have the function g of x, which is defined by a linear equation. So in this situation, right, you could graph this line, starts at 2, and it's negative 3 over 1, so down 3 over 1 with a negative slope, right? 1, 2, 3 over 1, right? So it's going to look like this. And then up 1, 2, 3, and over 1. It'll intersect there, up and over 1, right? So you can graph that line here. It's not going to be super easy to do that on the computer, right? So it says, which statements are true? Select all that apply. F of negative 2 is greater than g of negative 2. Well, f of negative 2 is 0. So that's 0 here. G of negative 2, I could look at this line and see that it's at 8. But you can also plug it in, right? So negative 2 times negative 3 is positive 6 plus 2 is 8. So f of negative 2 is not greater than g of negative 2. So that's not true. F of negative 1 is less than g of 1. So f of negative 1 here is 5. And g of negative 1 would be negative 3 times negative 1 is positive 3 plus 2 is 5. So they wouldn't be one wouldn't be greater or less than. They're equal to each other, and we see that where we drew the graph. But again, by plugging it in, we can prove that, so that's not true. F of 0 is greater than g of 0. So f of 0 is here. G of 0, if I plug in 0 here, I'll get 2. So 8 is greater than 2, so this is true. F of 1 is less than g of 1. So f of 1 is at its vertex here, which is 9. And then if I put g of 1, that's going to be negative 3 plus 2. That's going to be negative 1. So that's not true. It's not less than. It would be greater than. And then f of 2 is greater than g of 2. So f of 2 is here, right, at 8. And g of 2 would be negative 6 plus 2 is negative 4. And so that is true because 8 is greater than negative 4. So that is true. So in a situation like this, you're going to compare the points on the graph and then compare what you can plug in for x in the linear equation here. And so this, line would go like this. So you can also see after this point where they intersect, any number to the right of that, so any number greater than negative 1, our g of x, or sorry, our f of x is going to be greater than our g of x. Our line is going to be less than the values of f of x there. All right, let's look at, I should also note that this one is a calculator section. So this one you are allowed to use a calculator on. You probably wouldn't need to for that, but you could. All right, number 9 has 2 parts to it, or sorry, actually 4 parts to it. And these are systems of inequalities. So Leah would like to earn at least $120 per month. So at least $120. She babysits for $5 per hour at an ice cream shop and $8 per hour. Sorry, $5 per hour for babysitting and $8 per hour for the ice cream shop. She cannot work more than a total of 20 hours per month. Let X represent the number of hours she babysits and Y represent the number of hours Leah works at the ice cream shop. So we have 2 equations here, right? We have X plus Y. X is babysitting, Y is ice cream, and we can see that here on our graph as well. And it has to be, she cannot work more than a total, so less than or equal to 20, right? And then she needs to make at least 120, so greater than or equal to 120. But then money-wise, that's $5 per hour babysitting and $8 per hour at the ice cream shop. So then it's asking us which graph shows us the set of points that represent the hours that she can work to earn at least 120 and not work more than 20 hours per month. So first of all, let's look at these 2 graphs. These 2 graphs are almost exactly the same. We have a line at 20 and 20 here, 20 and 20 here, but then 15. So our lines are slightly different. So let's go ahead and map those out. So first of all, in order to graph these, 1, you can put them in the calculator, right? This is a calculator section. But in order to do that, you would need to solve for y. So let's solve for y. If we subtract 5x from both sides, we get 8y equals, let's do greater than or equal to negative 5x plus 120. divide both sides by 8. Okay, so we would have y is greater than or equal to, and then remember, if we're doing greater than or equal to, we can change this line to be above, right? That means greater than or equal to. So I can say okay, and then let's go ahead and put in our graph. So then it's going to be 5 over 8 negative, then we're going to do, remember, alpha, and then that little xt theta, that is where your fraction is. So 5 over 8x, and then plus 120 over 8. So 120 divided by 8. And you could actually also calculate that. That would be fine. So that's one of our equations, right? The other equation is this one. So this is going to be y is less than or equal to negative x plus 20. And so that one's nice and simple. But we're going to change this to less than or equal to. So enter, and then less than or equal to. And we're going to make this negative x plus 20 and graph that. Okay, so we can't really see that fully. Let's go ahead and make this, is that already standard? It is standard. So we want to zoom up and out a little bit. Let's see if we can take a look at that. So let's zoom out a little bit more. So zoom 3 out, press enter when you zoom out. Okay. So now remember, the part that is true is where that the overlapping is happening. So that's in this area right here. That's where the overlapping is happening. So that's where our solution is. So that means if we're over here, that we can eliminate A and we can eliminate C. But the thing now we need to look at is where these are crossing the axes, right? So the one y-intercept would be 20, which we have a 20 on both of them, right? But the other y-intercept would be, let's see, go back here, it would be 120 divided by 8. So 120 divided by 8 gives us 15. So the other y-intercept would be 15. And so that means it can't be B because B's other y-intercept is up here somewhere. And so D is going to be what our best solution is based on that. Now, you can, again, this is calculator section, so you could use a calculator. If you didn't use a calculator, though, you could still figure that out by identifying that this right here is the line that represents the hours that she is working. It has to be less than or equal to, right? So that side is shaded. And then the other line, because that has the y-intercept of 15, has to be greater than or equal to. And so the other side would be shaded above the line. Oh, I'm not sure what happened to my, there we go, okay. And so this little triangle right here is what the solutions would be, okay? All right, so that's part A. Part B says which pairs XY represent hours that Leah could work to meet the given conditions. So those hours need to be inside this shaded area. Let me erase this so we can see a little bit better. All right, so when we're looking at this, we want to see, well, which of these values would be inside those shaded areas? So 4, 15. So 4, 15 would be here, and that is in the shaded area, so that would work. You can also say 4 plus 15 is less than 20, so we know it works for that. And then we can also plug it into the equation here and see, is that greater than or equal to $120, right? So if we work 4, we would get 20 here plus, what was it, 15 times 8, which you might recognize to be 120. 120 plus 20 is 140, so 415 works. 5, 12. So we go 5, 12. Well, 10 is here, 15 is here. This is like 12 and a half then, right? So 12 would be just under that. Let's see, we have to plug that in then. So 5 plus 12 is less than 20. That works. So 5 times 5 is 25. 25 plus 8 times 12. So 8 times 12 is 96. Plus 25 is 121. So yes, barely, right? We look at 10, 9. That also looks like it's pretty good. It's a good contender. 10 times 5 is 50. 9 times 8 is 72. So 72 plus 50 is 122. So that would also work. 15 comma 5. So we do 15 comma 5. That's down here. So we can see very clearly that is not in the gray. That is not going to work. And then similarly, 19 comma 1 is going to be all the way down here. That will not work. Okay, so A, B, and C do represent it because they are inside this gray area here. So this is dependent upon you first recognizing the correct graph, right? Part C, if Leah babysits for 7 hours this month, what is the minimum number of hours she would have to work at the ice cream shop to earn at least $120? So we can plug into our equation 5 times 7 plus 8y has to be greater than or equal to 120, right? And so this would be 8y is greater than or equal to, this is 35, so I can subtract 35 from both sides, and we get 85, divide both sides by 8, and we'll get 10.625. It says give your answer to the nearest whole hour, so she would need to work 11 hours, and that would give you 88 plus 35, which gives you 123, so we can check that. That works out. Part D, Leah prefers babysitting over working in the ice cream shop. Out of 20 hours, what is the maximum number of hours she can babysit to be able to earn at least $120 per month? Give your answer to the nearest whole hour and enter your answer in the box. Okay, so out of those 20 hours, if she wants to babysit and she wants to still meet the maximum, right, that she can do in order to do that, right? Her hours of babysitting, the maximum hours that she would babysit, right? It looks like are here and still be able to be in that gray zone, right? So that's looking to be about maybe 11 or 12, but we want to calculate exactly to see where this intersection would be. So what we can do then is we have 5x plus 8y is, we'll make it equal to, okay? And then x plus y equals 20. Do that right? Let me make sure. Yes, okay. And so now we want to see where are they going to intersect, because that'll tell me the greatest number of hours that she can work babysitting, right? And so what I'm going to do is I'm going to multiply this whole thing by -5. So it's going to be -5x minus 5y minus 100. And so this will cancel out, and we'll get 3y equals 20. And so then 20 divided by 3 is going to give me a decimal of 6.67-ish. Okay, that gives me how many hours she would work at the ice cream shop. And so if we were looking for how many hours she can work at the babysitting for $5 an hour, right, we can plug that in back in and solve for x, right? So if we have that times 8, and then 120 minus 53 is 67 divided by 5 gives me 13.4. So to the nearest whole hour, we would say that she would have to work 13 hours babysitting, and then she could work 7 hours at the ice cream shop. If she were to work 14 hours babysitting and 6 hours at the ice cream shop, she wouldn't make enough money, right? So if we were to plug that in, we have 14 times 5 plus 6 times 8, which is 48. That gives us 118. So it's just a little bit short. So that's why she needs to do more hours ice cream shop working, because she makes more money there, right? So the minimum or the maximum number she could babysit and still make the proper amount of money would be 13 hours. Okay? All right, so that is A, B, C, and D for number 9. It's a pretty long problem, so I'm going to pause there and upload this, and then I'll do another video for number 10.